holds a sustainable forest license to manage the Bancroft Minden Forest, a Crown Forest Management Unit with over 250,000 hectares of productive forest available for timber production on behalf of 25 different shareholder companies. She is currently developing the 2021 to 31 Forest Management Plan, and as of this coming September, will take on the added responsibility of General Manager of the company as the first woman to act in this role in the southern region of Ontario. She started her career modestly, working in the trenches, planting trees in 3 different provinces. Those trees paid for her education, and since graduating with an Honours Bachelor of Science in Forestry from Lakehead University, Svetlana has worked for the non-profit sector, government, and industry in various capacities. She has a passion for sustainable forest management and is developing strategies to build resilience in the future forest to withstand future attacks from pests and diseases in a changing climate. I'd like you to join with me in welcoming Svetlana Zeran as our speaker.
Thank you for that introduction, Neil. And it's a pleasure to be with you all tonight, so thank you for inviting me. I guess I called into the Ed Lawrence show a few months ago and the topic was beech bark disease, because I just felt that there needed to be somebody representing foresters and the devastating impacts of this disease on Crown forests. And from that quick segment when I called in, I guess Neil had heard that and he reached out to me through our website, so it's kind of surprising. You never know where these things will lead, but it's a pleasure to be able to come out to an association with committed forest stewards and be able to share some of this knowledge with you all, because I think it is a very serious thing that we are struggling to deal with, certainly on the Crown Forest. So because that is my, really my knowledge, it's all about managing the Crown. That's what I'm going to focus my talk on tonight. However, I'm sure a lot of the treatment ideas that I'll share and silvicultural options will also be relevant to you all when you're thinking about maybe how to manage the disease on your forest. So by a show of hands, how many of you are familiar with beech bark disease? Amazing, all of you, okay. And how many of you have it on your property? Yeah, so it has spread violently fast, and on the Crown Forest, we've been fortunate to be able to secure funding through the Forestry Futures Trust Fund. So that is essentially a bank account where whenever you harvest timber on Crown lands, a part of the stumpage fees go into this account, and that's a special purpose account that you can write proposals for funding different efforts to control diseases, to do some reparations after forest fires, all that kind of stuff. So basically helping to restore forests after things that are out of our control. So I'll talk a bit about what we've done to control beech bark disease on our forest. So, is this working for you? Or?
Yes, that's fine.
Perfect. All right. So just a little bit more about Crown land forest management. I'm not sure how many of you are familiar with it, but Ontario is obviously a very big, diverse province. So for the sake of making forest management a little bit easier on public lands, the province is divided up into 41 different geographic planning areas known as forest management units. So we are down in the southern region, so there's 5 different forests in that region which are all overseen by the Ministry of Natural Resources and Forestry out of Peterborough. And then each of them also has their own office, usually somewhere in the middle of the actual planning unit. So we're just below Algonquin Park, and we're one of the most southern forest management units within the area of the undertaking, which is essentially where you can practice forest management on an industrial scale on Crown land. So this is the Bancroft Minden Forest, and what makes it unique is that more than half of it is actually private land. So in total, this area is around 440,000 hectares, but when you remove, and that's just the crown, so when you remove all of the parks and protected areas, the non-productive areas like swamps and areas below regeneration age, the lakes, all of that, you end up with around 250,000 hectares where the timber is of a mature enough age that it could be available for timber production. So that's what we're working with there. And we're managed by quite a small company. There's only 5 of us. And then we're hired on behalf of 25 shareholder companies, which range in size from pretty large sawmills to just ma-and-pa loggers, independent loggers. And since 2012, we've also been Forest Stewardship Council certified. So that's just an additional effort that we do to basically hold ourselves to a global strict standard of sustainability, and we're audited every other year to make sure that we're maintaining that practice. Oh, well, that's not good. Okay, so as a sustainable forest license holder, we have to plan. So we develop the forest management plan for 10 years, and you have to have a 10-year forest management in place before any timber can be cut on Crown land. And we also develop an annual work schedule, which basically details each year where our activities are going to be and what we're going to do. We also are responsible for conducting our field work, and we write silvicultural prescriptions that detail what will happen. And that involves a lot of walking through the bush. So we actually walk every stand and we come up with a plan for it, and it's all certified by a registered professional forester. Then we monitor our operations to ensure that they're all harvested sustainably. So we have a pretty rigorous compliance program, and then we're audited by the Ministry of Natural Resources as well. And we're responsible for renewing all the areas that we cut. And then we also have to report each year on our progress to achieving our goals as set out in the 10-year forest management plan. So our forest, we're in the Great Lakes St. Lawrence, and as you all know, that's a very diverse, complex forest. So I'd say it's more, certainly has more challenges than in the boreal. There's lots more silvicultural systems that we employ here to regenerate the forest. And some of the reasons that it's so complex is we have such a diversity of tree species with very heterogeneous forested stands. I think one of the unique challenges where we are is virtually half the population of Ontario can drive within our forest in about 2 hours. So we're under a microscope and heavily scrutinized. We also have a lot of interactions with private land because some of our Crown land is virtually landlocked by private land. So we have to develop a good social license to practice and get people to grant us access oftentimes. And there's quite a long history of utilization, which I think the same could be said for all of Ontario, but especially down here was one of the first areas to be cut for white pine and everything that followed that. So those effects are still being felt on the landscape today. And also different past management practice. So we didn't always have the same sustainable practices as we do today, or the same understanding and science of silviculture that we do today. So we're still dealing with that as well. We don't have the greatest forest resource inventory. It's done at such a coarse scale, which requires us to physically go out and get our boots dirty and walk all of that land. So that can be challenging. And then, of course, there's a bunch of other things like acid rain, droughts, insects and disease, amongst others. And I think being a younger forester and coming into this profession, this day and age, a big big challenge that I'm going to have to face in my career certainly are these invasive pests and diseases, which I think a lot of the foresters that have come before me and who have since moved on didn't necessarily have to deal with on the scale that we have them today, and it's only going to get worse. So, something else that's unique about our forest is 96% of our activities are rely on natural regeneration. So a lot of what we do is partial harvest, and that's accomplished through single tree selection, shelterwood management, where we're removing maybe between 30 to 60% maximum of the canopy, so leaving enough trees to seed in and regenerate the future forest. And we really rely on our tree markers. So since 2011, we've actually tree marked over 15,000 hectares of crown land, which I think is a true testament to sustainable practice. So I don't know if any of you have had a tree marker come out and do work on your property, but you can see that a lot of thought goes into that. A certified tree marker assesses every single tree and determines the ones that are healthy and the ones that are unhealthy, and decides what to take and what to leave, with the premise of basically take the worst first, right? So through time, tree marking really does improve stand quality, so it improves forest health. And right now, with some of these diseases that we're contending with, like beech bark disease, it's essentially rendered the entire beech component of our forest UGS, or unacceptable growing stock, and those are prioritized for removal. And that's had pretty significant economic impacts to our mill owners, because the sawmills, the local one in Bancroft, tells us that less than 5% of the beech that's coming into their yard is actually of good enough quality to make it through the sawmill. The rest of it is pulp, and a lot of the pulp mills won't even take it. So what do you do with that? And think about the fuel and cost to truck that material out of the forest and get it somewhere if you can't do anything with it. So by prioritizing forest health and saying, okay, we want this beech to come out of the bush, it's sort of displacing other more economically viable trees and product that they're not able to access. So that's something that I think isn't talked about enough in the province, but it's a pretty significant impact, and it's certainly being felt by our mill owners and loggers who are losing a lot of money. Oh, it's nice. Okay, so just a little plug for one of my mentors, Ernie Dillon. He came before me. I've only been at the company for a couple of years, and he really was the one to first notice that beech bark disease was a problem and come up with a plan of how to manage it. And recently he was actually contracted by the government to write what's probably the most extensive report on the status of beech bark disease management in the province. So I can always email anybody that report if they're curious, but that's a good one to check out, because he did a lot of interviews to write that. And that's him standing beside a very unfortunate diseased beech tree. So it's good that you're all familiar with beech bark disease. We started to notice it about 5 or 6 years ago in like epic proportions. And it is a combination of a scale insect, which is these little waxy kind of looking guys that are really hard to see, and they vector the fungus. So the insect will basically inject the fungus into the bark of the tree, and then that fungus will clog up all the conductive tissues, and it forms these diffuse cankers, which essentially starves the tree of being able to translocate water and nutrients, and it suffocates it and starves it of water and nutrients. So over time it gets very stressed out and it dies. And in the beginning, we were seeing a lot of trees that we thought were resistant. So we'd get the tree markers to mark them with blue paint. Blue is the color to keep. thinking, okay, well, you know, there's beech bark disease all around here, but this tree seems healthy. So we were marking them in blue to keep. And then we'd come back to check on them the next year, and unfortunately, they were not resistant. So, and it also was kind of an odd thing that it seemed like wherever you put the blue paint, that's where the insect would go. So things that we already know. 99% of beech in Ontario will be affected, which equals death. So we anticipate an additional 50 million trees or so to die in the next decade. So it's also very unfortunate that the 50 million tree program was canceled, because that could have maybe balanced it out a bit. So they estimate that some resistance may occur, but it's about less than 1%. But it's currently impossible to predict the winners, right? There's no actual characteristics that you can see on a beech tree that can let you know that it's resistant at this point. We just don't know. And it's going to cause some silvicultural problems. So this is especially a problem if you live or work around a lot of beech trees, because they're a high risk of falling over. It's very dangerous, but it's an even bigger problem if you're a forester tasked with sustainably managing a forest that's full of beech trees. What do you do? So this map is a little bit old, so I apologize, but this is just to show you that the beech first came into Nova Scotia in the late 1890s. And since then, it's slowly cracked its way across the entire range of American beech. And once it got to the Canadian Shield, where the soils are not as, deep and nutrient rich like they are in the States, it just spread like wildfire. So in a very short time, it devastated our forest. And this is what we call ground zero, where it was sort of first detected near Dorset, Ontario. And this map is showing all the forested stands with greater than 10% of beech in the overstory composition. So there's almost 600,000 hectares. So that's a lot. And a lot of that, as you can see, is within the geographical area of our forest management unit. So just to go through the phases of the infection, we kind of call it the advancing front. So the beech scale comes in, has a rapid expansion, little evidence of the fungus, which is those red fruiting bodies at that time. But the beech snap can occur at that time, so that's where literally the beech tree will just snap in half. And that actually happened in Killbear Provincial Park, where they had to get rid of a lot of beech trees. Then you have the killing front, so that's an extremely high population of the beech scale, heavy overstory mortality from the fungus, almost 100% are impacted, increases the canopy gaps. So you might get a lot more light coming in, which stimulates understory vegetation growth. And in terms of mortality, from studies we've seen it's about 20% in 2 years, 50% in 10 years, and 80 to 100% over time. So unfortunately, a lot of the Bancroft Minden Forest right now is what we call the aftermath forest. So the disease is lingering. So once the disease comes in, it essentially remains endemic. So it's always there. You can't get rid of it. And any new tree that comes in that's a beech will just get reinfected and it won't reach maturity. And that, unfortunately, causes beech thicket. So the point that I was trying to make on the gardening show is it's really sad to think we're going to lose all of these beech trees, but that's not really the issue. It's what I call the zombie forest that's going to come in after all of those big, lovely beech trees succumb to the disease. they keep resprouting through root suckering, and that stimulated growth just gets reinfected and reinfected, and it won't reach maturity, won't produce beech nuts. So that's really where the issue is. And I thought it was interesting that Beech Bark disease is actually the first known case where a specialist plant pathogen increases the abundance of its host. Who knew? So yeah, they resprout aggressively from the damaged root sprouts. And there's, say, about 60 to 90% will come back from a root sucker origin, although a lot can come in through seed, because as we know, when trees are unhealthy and they start to die, they also produce a ton of seed. And unfortunately, machine travel actually doesn't help. So when you come in and you send a skidder in, just driving over the ground can stimulate a bunch of new root production. So what we've seen in these thickets is that the beech saplings cluster around the dead canopy trees, and majority of them being within 10 meters of the parent. And overall, we have a shift to younger, smaller forests over time as these thicket conditions take hold. Beech have a huge advantage over sugar maple. They have a more efficient leaf display, and they have more efficient lateral growth. So they just outcompete sugar maple. So where you have these thickets, the sugar maple just can't stand a chance. So these are photos taken from Nova Scotia, where they've had the disease now for over 100 years, and the beech is just a shadow of its former self. And they have these thicket conditions where they're essentially biological desert, so that's all that grows there. But they'll never be mature, so they're all just kind of these scraggly little guys. And foresters from Nova Scotia come to Ontario, and they don't even know what a healthy beech looks like because they've never seen one. So this is a typical healthy specimen of American beech, which we're all familiar with. And this might be the future of what they'll look like. So surprisingly, New York, Vermont, and Pennsylvania can now claim that beech is the most prevalent understory species. And it had a huge increase over the past couple decades. And obviously this has huge consequences on wildlife. So in Maine, 80% of sows will reproduce after a good mast year, so a good seed year, but only 22% will if they don't have a good nut year. And beech nuts have 1 to 6 times more fat than other mast sources. So, we can promote a lot of oak and other species, but it just won't give them the same nutrients and fat that they really need to make it through the winter. Another issue is that deer don't like to browse on beech. So if they have a choice, they'll always pick a sugar maple or a yellow birch or something. They'll leave the beech to the last. So this accumulating leaf litter on the forest floor, which is very acidic, there's lots of tannins in beech leaves, which is why you can see them pretty much all winter long. They hang on to those leaves, right? And they take longer to decompose than any other leaf. So from that accumulating leaf litter on the forest floor, it can actually change the soil composition, further favoring beech. So as you can see, this problem just gets worse and worse. And over time, that diversity decreases. And so studies have proven that where the understory beech exists, that beech will prevail, even in very low overstory compositions. So in 2016, our company submitted a Forestry Futures Trust proposal to control beech regeneration, and we were successful in securing the funding. So this is a summary of treatments to date. We've done some chemical treatment and also mechanical treatment. But you can see that these treatments are extremely costly. I mean, they keep going up in price actually, so we're sitting at around $750 per hectare to do this treatment. We also set up a trial in partnership with the Ontario Forest Research Institute, OFRI, out of Sault Ste. Marie. So they have scientists who set up this control study to look at different treatment methods in a beech-dominated stand to answer a bunch of questions. So they wanted to know, or they're hoping to learn, what the relationship is between the abundance in the overstory and the understory. So thinking if we knew that relationship, could we predict where the most prolific thickets will occur? What treatments will work best in the understory? Does timing of treatments matter? So is it most effective to treat before, during, or after a harvest? Are multiple treatments needed in order to promote the regeneration of other species? Can beech control tending operations assist in establishing other important mast and wildlife species? Can they increase species diversity? What will the cost be of doing these treatments operationally? And what are the short, medium, and long-term stand level growth and yield consequences of treating or not treating these stands? So as you can see, there's a lot of unanswered questions, and I think this is just a small list. There's a lot more things that we've been thinking about too, and it's going to take a very long time to get some answers. So this is what a typical stand will look like pre-treatment. So that's a ton of beech. And first I'll talk a little bit about different understory treatments that we employ, and that might be useful information to you folks who might be struggling with the same understory thickets. So they say prior to harvest is really ideal, but I mean, of course you can treat the understory beech even if you're never planning to do a harvest, or after the harvest. So first, we've done a lot of brush saw tending, and in our forest, a big pro of this is that it's not a chemical. So a lot of times when we have crown land adjacent to cottage lakes, the cottagers really don't like the idea of using chemicals, so we sometimes have to do brush saw treatments. And I guess another advantage is it can be done without a pesticide applicator's license. But some of the drawbacks to brush saw treatments is that the beech tend to aggressively resprout afterwards, so it can actually need to be treated more than once. And if you're looking at $500 to $700 per treatment, you really want to get it in one shot. You don't want to have to come back and do it again. So another drawback is it doesn't kill adjacent stems like chemicals would. And it's extremely labor intensive. If anyone's operated a brush saw in a thicket like this with 10,000 little stems, it can be quite a lot of work and potentially dangerous too when you've got all of those stems falling towards you. So the chemical treatment that we've used, which has had amazing success, it's called triclopyr. And what we do is it's very species specific. So you essentially have this little wand, you touch the base of the stem, and that chemical will just affect that tree. It has a very, very short half-life. It doesn't persist in the environment. And then it gets absorbed into the root system, and it kills all of the neighboring stems and will essentially eradicate it forever. So within one season, we can see all of those little guys are dead. You can also use glyphosate, which is, I know some people take issue with that chemical, especially in the news lately. It's not great, but you can do that. They've done that in the States a lot, where they've done these little frill cuts with an axe, and then you just squirt the chemical there, and that also is quite effective. So that's called hack and squirt. We've also tried this, which is a cut stump treatment. So after a harvest is performed and you have a lot of these stumps around, you can actually paint some glyphosate just around the rim, and that prevents the rescrubbing of the beech. So this is what that stand will look like post-treatment. So other silvicultural or harvest options, we really had to change it up because single tree selection just doesn't work anymore. And that's really how we've been managing our tolerant hardwood stands, where beech makes up, it freely associates with sugar maple. So you've got these really nice healthy sugar maple stands with a beech component. We normally just apply that same standard single tree selection silviculture all the time. You didn't have to think much about it. And we realize now that the long-term compositional outcomes of applying single tree selection actually just increases the abundance of beech, because it doesn't quite let enough light in to stimulate some of your mid-shade tolerant species to last in the overstory. So like your oaks and your yellow birches and ash, you just lose those over time. So we realize it's just not working anymore for us, and we have to change it up. So basically, anytime we have a stand with more than 10% beech in the overstory, or where the beech is like more evenly distributed through the overstory, we're not doing single tree selection anymore. And this is really what a typical forest stand looks like in the Bancroft Minden Forest. It's just so variable that it's not uncommon to encounter a tolerant hardwood stand with more than 15 unique species tallied in your pre-prescription cruise. So as you're walking along, you see, little patch of textbook sort of hardwood selection, tolerant hardwood forest. But you might move a little bit further and you see this advanced yellow birch regeneration. Maybe you have an advanced hardwood understory with a declining sugar maple overstory, which might be like a legacy of past management practice. And that might tell you want to do a final removal. So take off the older unhealthy trees and let the understory be released. And sometimes you have these little poplar patches, which could actually benefit from more heavy cut. So we have these mosaics of different species, different ages, different distributions, and that's really more of an irregular stand. And in Quebec and the northern US, they've been practicing irregular shelter wood. So, and then of course you run into your beech patches too, and your oak. And all of these scenarios will be found in the same stand, sometimes within 10, 20 meters of each other. So as a forester, hard to come up with a kind of approach that can deal with all of these conditions effectively, given that each species has its own silvical requirements, needs different amounts of light, and how do you manage them all at the same time, right? But there is a method, and it's called irregular shelterwood. And so we've looked to Quebec and the northern US to see how they're handling this, and they've had really good success with using irregular shelterwood. So this really relies more on structural retention and advanced regeneration, which are the fundamental basis of a shelterwood system. And they also maintain, increase, or create heterogeneity within a stand, which allows complexity to develop over time, which is extremely important in changing climate with lots of pests and diseases. And the other cool thing about this system is that you can allow different openings with different amounts of light, so you have the capability of both regenerating shade intolerant and mid-shade tolerant species in the same stand. But unlike single tree selection, irregular shelterwood does not attempt to balance the age class, because single tree selection has usually very strict requirements on how they want the final stand to look like. And they also use a diameter at breast height, so that's using a prism to kind of count how much basal area you have, and that's what they use as like a regulation control. We don't do that in irregular shelterwood. It's applied a little bit more free in space and time. So irregular stands are diverse, resilient, and adaptable, and that's why we're favoring this approach. And we're really writing it in as like the approach for managing tolerant hardwood stands in the next forest management plan. So this is just some examples to kind of visualize it, because I know it can be tough to picture what that looks like in practice. But instead of taking a basal area control and applying that across an entire stand with this broad stroke paintbrush, this requires the tree marker to be really vigilant and assess each tree at the tree level and think critically about what requirements it needs, right? And our tree markers are already out there, they're already looking at every single tree, so they really are best positioned to carry out this kind of system. So for example, you might have this advanced acceptable regeneration. So they would want to remove the overstory of unhealthy beech or unhealthy, older mature trees to release that. So then the tree marker would have to make that decision. There's also the concept of an expanding gap. So you might have these patches of things like yellow birch, which we want to encourage. So as a tree marker, they would essentially cut a swath all the way around that yellow birch and allow it to expand out in space. Technical difficulties. Yeah, so anyways, in this diagram, that's just showing that all of those trees would be removed, and that would allow that nice, beautiful golden yellow birch to seed out. So essentially, this system really just tries to embrace diversity in the forest. So really just trying to look at what we have there, what's healthy, what wants to grow, what's the soil supporting, and encouraging that. Another system that we've had to employ in some areas is a clear cut with yellow birch seed trees. So in some areas of our forest, especially around the Dorset area, we have stands where 50% or more of the overstory species composition is beech. So what do you do in that situation, right? You need to take a heavy-handed approach to dealing with it, otherwise it's just going to decline over time and become like a desert. So in this case, we would have our mature stand. We'd select the best, healthiest yellow birch trees with the largest canopies, and we'd clear everything else and allow them to seed in. So this is an example of a cut that we did where 50% of the overstory was beech. And this is what it looked like after. I know it's quite extreme to see that. But by the summertime, it's starting to look a lot nicer. And you've got beautiful red oak coming in. and tons of yellow birch. So that's going to be a beautiful yellow birch forest in the future. So the challenges that we've had to deal with so far is that these beech understories tend to be extremely patchy. Like they can range from having, densities of 200 stems per hectare to 10,000. So it's really tough to assign like a per hectare rate or to prioritize where you do your treatments in the absence of literally walking through all of the areas. It's just a lot of work to back that out. Also, forest practitioners from the south who have been dealing with this disease for much longer than we have told us that in order to be like super successful, you'd want to go in 5 to 10 years prior to your harvest, kill off your beech, and then have a plan so that other understory species can take advantage of that space, so that you don't run the risk of harvesting it and then just encouraging a ton more beech sprouting, right? But I mean, it's really hard for us to plan that far in advance, especially when we've got 25 different operators who have their own schedules of how they want to cut their harvest allocations. So another big issue obviously is cost. As you saw, the costs to do these treatments is extremely expensive. So right now we've been floating about 20% of the cost, and the Forestry Futures Trust is 80%. So with treatments, ranging up to $1,000 per hectare in some cases, it's a lot of money. And essentially all of our money that we have for silviculture comes from stumpage. So when our operators cut a typical single tree selection stand, we get about $110 back in stumpage. And of that money, $70 goes to tree marking, and most of the rest is eaten up by us coming out to check on, do our surveys, do our follow-up. So there's really nothing left afterwards to do these treatments. So in the absence of continued funding, we won't be able to do this. And we just lack capacity in our forest. We harvest less than 0.5% each year. So right now we average like 1,900 hectares out of the 250,000 that's available. So that's quite a small area. And same thing in Algonquin Park, all of the southern region, they're not cutting a lot of wood. In fact, utilization rates are the lowest that they've ever been, especially in the past 5 years. And our forest sector just isn't thriving. So we're all nobody's getting rich off of forestry anymore. And we estimate that at this rate, if we're coming in and we're essentially ignoring every other stand that doesn't have more than 10% of the species composition as beech, we're ignoring it, we're just targeting those stands, it would take us 100